in Canvas. So my apologies for that, but it's kind of sort of similar. Homework's going to be pretty similar all the time. There's usually going to be a question about what was the main point of the lesson on paper we just went through, and then some follow-up questions that either repeat things you did in the lesson or extend it a little bit. So I think question 2 is what I want. Yeah, let's blow this up so you can all read it. Oh, shit. It's pretty blown up. There we go. So, turns out the statement on the billboard was reworded from the original statement that appeared in a news article. The original statement appeared in a news article in 1995, and it said every year since 1950, the number of American children, the number of American children gunned down has doubled. That's the reworded one. Original, there we go. The number of American children killed each year by guns has doubled since 1950. That's a different statement, isn't it? Okay. So read that a couple of times. Think about it. We're going to travel back in time to 1995. Not 1950. 1995. Okay. So everyone read that a few times? Got it firmly planted in your head? Pause as you read again. Okay. And we're going to make a new spreadsheet. Where's the spreadsheet? Right here. So here's the crazy spreadsheet I made before, where we're doubling, and I'm going to put 100 people in 100 kids were killed by guns. Died by gun. That's what the original statement referred to. Because what the hell does gun down mean? We talked about that. So if we double 100, we get 200. Double 200, we get 400. That's doubling every year, right? Okay. So this is from the reworded statements. Reworded. Now I'm going to make a new spreadsheet for the original. Okay, so we need to know the year. Remember, every time we play with a spreadsheet, we want to label stuff. Good habit, label first. Because otherwise, if you start throwing numbers in there, you're probably never going to get to the labels if you're anything like me. And then kids died. That's no label. All right, year, 1950. We're going to go with 100. Year, 1995. That's where we are now. We're in 1995, right? Okay. Talk amongst yourselves. Come up with a number for me for 1995, given the original statements. Nope, that one. Where'd you go? Ah, there you go. Original statement is this one right here. Number of American children killed each year by guns has doubled since 1950. Write something down. Check with your neighbor. What do you got? I'll give you 2 minutes. "30 seconds. Everyone got an idea? Right. Make something up then. Make shit up. That's it. Make a number up. In this class, it's better to guess and be wrong than to do nothing because you're afraid to not be right. Embrace math without fear. All right, Jose or Daisy, you guys want to throw out a number, or are you good over there? Okay. So by the way, there is a chat in Google. So if you ever want to type me something instead of speaking up, the blue button in the upper left when you point over there brings up a chat screen on the right, and then you can send me secret messages. I have a very shy student in another class that prefers that to speaking. All right, anybody in the room here want to give me a number? Trillions? 200? Who said 200? Colt? Is that right? Colt says 200. I agree with Colt. Okay, so let's pick this statement apart. Number of American children killed each year by guns. Okay, that's part of the statement. Does it say doubled each year? No, it just says the number of kids killed has doubled since 1950. So it's really 200. Yeah, so the original statement, if there were 100 kids killed in 1950, in 1995, there were 200. Now, we looked up a number the other day in class that was something in the thousands. Does that sound right? Remember we Googled this in class yesterday? Anybody recall, Colt? You seem to be the man with the answers. It was in the thousands, right? Like 4-ish, 5. Yeah, that's what I recall. So, you know, I can see, let's see, if we dug, so how 1995 to 1950 was how many years? 45 years. Since 1995, it's been what, 20-ish and 20-something years? That 4,000 seems a little high, but maybe gun violence has gotten worse over the last couple of decades. That's a possibility. Is this something that requires more research to really think about? Yeah, pretty much. We need more data. But there is a big difference between the original statement and the reworded statement. The reworded statement is basically telling us to double each year. It's replacing children killed each year by guns with gunned down, right? So not only is it inflammatory, it's incredibly numerically inaccurate. Look at our spreadsheet from the other day. It's crazy numbers. So this should be 200. And if I go another, if that stays like a fixed pattern in another 45 years, so if you're going to do a calculation in a spreadsheet, you do equals first. I want to take the previous year and add 45 to it. So in 2040, we should take the previous number killed and multiply by 2, right? Double it. And spreadsheets are awesome at doing stuff like this for us. Yeah. So it wouldn't, if the pattern continued that they discovered in 1995, we would expect only 400 in 2040. We're somewhere in between, right? So like halfway, pretty close to halfway in between. So maybe in this year it should be like 300 killed, but we saw an article that said more like 3,000-ish. So we definitely need more information. But the reworded statement was incredibly inaccurate because what did we get? 1995 even. We didn't even get to 1995 when we had nuts and numbers. Let's see, what do we got here? Thousands, millions, billion, yeah, 54 trillion in 89. Okay, so we're going to pause for a minute and just talk about big numbers. I hear trillion all the time in the news. Do you guys? Where do we hear numbers like billions and trillions? Give me a couple of examples of where we hear those in the news.
National debt.
National debt, okay? There's also national deficit. Those are two different things. We'll focus more on those in a later lesson. Okay, what's the difference between them? Other things we hear about big numbers like that besides our national debt or deficit. Number of turtles in the world, I don't know, come on, help me out here. Gross domestic product? Maybe. People in the world, how many people are in the world right now? 6.5, 7.5 billion right now, I think. Yeah, there are these counters online you can look up. Yeah. How many people in the US right now, roughly? I think it's 300 million-ish right now, if I remember right. So millions US population, billions world population, billions national deficit, trillions national debt. Because debt is accumulated deficits, deficits from 1 year, right? Okay. So let's try to wrap our mind around this. So does everyone have a blank piece of paper nearby? You have a blank piece of paper. You don't have to tear it out of your book or anything. I just need you to look at a blank piece of paper. Okay? So if your blank piece of paper, let me get a blank piece of paper on here. No, not there. Let's go over here. New Google Doc. Okay, so here is my blank piece of paper. Zoom the other way. Okay, I can almost see the whole thing. That's almost the whole thing. There we go, there's the whole thing. I want to rotate my paper to go the other way. Can I do that? Page setup, landscape. Okay, so there's my paper. Everyone rotate your paper so it's landscape like mine. And then what I want you to do on this piece of paper, and switch to one I can actually draw on. I want you to, on one side of the paper, make a mark and call that 0. And you can do it somewhere off on the edge so you don't ruin your whole piece of paper so you can use it later. Like a lot of you have those rule things with the red line. Use that red line. And then over on the other side of the paper, make another line. Call that 1 trillion. So let's say, I was going to remind myself about trillions. I'm going to, let's see, 0, 0, 0, ones, tens, hundreds, 10,000, 100,000, no, 1,000, 10,000, 100,000. There we go. What's next? Millions? Millions, 10 millions, 100 millions. What's after millions? At least in this country, yeah. Billion, 10 billion, 100 billion. Holy shit, that's a big number. And finally, 1 trillion. Okay, so there's 1 trillion. That's a lot of zeros. I'm kind of lazy. So instead, I'd rather write that as, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 zeros there if I counted right. You with me? So this would be 10 to the 12th power with an exponent notation. Okay. That's how I would write that. So 1 trillion, I abbreviated, trillion, can be written in a variety of ways. I have them there. All right, so aside from that for a minute, so you have this number line, right? So here's what I'd like you to do. Think about how big a trillion is. Imagine something that is a trillion. Distance, I don't know, bills, chocolate. Now, imagine a billion. Okay, so let's say you're a trillionaire. Okay? I'm a billionaire. We're both rich. Hey, rich guy. We're gonna hang out together because we're both rich, right? Probably. You think? We're both rich people in Pendleton. Not a lot of billionaires and trillionaires in Pendleton, so we're gonna hang out together because we got a lot in common, a lot of money. So here's what I'd like you to do. On your number line, make a mark as to where 1 billion lives. Just guess. Don't worry about it being perfect or right. Just throw something down there. Gut instinct, throw it down. Who cares if you're wrong? So I'm going to throw a number down there. Red. I think that's for billions. Let's double check that. Let's see. If the distance from here to here is 1 billion, then that means 2 billion should be right there. Oh wait, that's a trillion. Is 2 billion the same as a trillion? No. Just a reminder, right there, that spot is the billions place. Okay, so is my number too far to the right? It's too far to the right. I need to move it more to the left somewhere. Yeah. Okay, I have left-right troubles. Somebody told me that if I hold my thumb and finger up like this, that tells me what's left and what's right. But they both look like L's to me. Like, did not help. Anyway. Okay, so I need to move it over. So maybe I move it, so that was bad. Maybe I move it right there. Am I closer to 1 billion? If that's 1 billion, then 2 billion, 3 billion, 4 billion. Is 4 billion the same as a trillion? Shit, it's not in the right spot yet. Any suggestions as to where I should put it? Like right next to 0, like maybe right there? I still think that's too far to the right. It needs to go further left. What? A billion is close to 0 compared to a trillion? Yes. Let's double check why. So if I cut off that group of numbers right there, what's left are the billions, kind of. So how many times bigger is a trillion? What's that? Anyway? How many zeros different is it? 3 zeros, right? 3 zeros gives us what number? 1,000, right? Tens, hundreds, thousands. Or sorry, wrong way. You know what I mean. Right? Isn't a 1 with 3 zeros 1,000? So if you take 1,000 times 1 billion, let's do this together. That means we have 1,000 times a billion. So a billion is, let's see, 100 million, 10 million, million, 100,000, 10,000, thousand. This always blows my mind. 100, tens, ones. Okay. Oops, 0. So ones, tens, thousands, 10,000, 100,000, 1,000, 10,000, 100,000, million, 10 million, 100 million, billion. Yeah, I got that right. What happens when you multiply something by 1,000? Doesn't it just add 3 zeros to the right? So the result of that right there has to be a 1 with 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 1,000 billion is a trillion. So if I put this in the right spot, and then I marked off every single billion from here to a trillion, how many marks do I have to make? 1,000 marks. Holy shit. So this distance right here needs to be 1,000th of that distance. Now, let's rethink this. He's a trillionaire. I'm a billionaire. Are we really in the same club? Hell no. I'm pocket change to him. We are not in the same club. He could use billion-dollar bills for toilet paper and wouldn't notice. Oh, all right. We're going to play with this lesson in lesson 2. So lesson 1 is going to build into lesson 2 a little bit. That was exciting, huh? Are you guys blown away by the difference between a million and a trillion? So I'd known all kinds of math. I could do calculus. And I remember the first time I really thought about this, I was in my 30s. Holy shit, really? They're not much different. Wow. That's nuts. Okay, so they are hugely different. Is a billion different from a trillion? Yeah, so I'm a billionaire, you're a millionaire. Are we in the same club? We ain't in the same club. Yeah. 1,000 to him will make me. 1,000 to you, I don't need that many friends. I only need 1 or 2, I got plenty more. Okay, so big numbers. When I write stuff like this, those are called powers, right? There's a base and an exponent. So let's just review that a little bit. So powers, and writing in red's bad. Looks like I'm angry. Oops. Let's pick that color. All right. Powers. So something like 10 to the power, what did we have, 12. Just a reminder, the 10 is the base, the 12 is the exponents. What does an exponent tell us to do? It tells us to multiply, right? So just to keep in mind, it doesn't tell us how many times to multiply. Just look at a simpler example. Take 3 to the second power. That's 3 times 3, right? How many times did I multiply there? Once. Really? Once. That's one multiplication. I'm only multiplying once. What the 2 told me is how many times to write the base. That's what the exponent really tells us. Now, we often say it's how many times to multiply. We all know what we mean, but it's actually not correct English. It's not really what we do. Second power, I only multiply twice. No, oops, you messed me all up. Once. If someone said, what's 3 to the third power, that would be a 3, a 3, and a 3. How many times am I multiplying there? Actually, only twice, right? Because I would say 3 times 3 is 9. That's one multiplication. I have another 3 to multiply by. Now 27 is the answer. So the exponent doesn't tell us how many times to multiply. It tells us how many times to write the base. So with that in mind, 2 to the first power, how many times do I write the base? 1 time. Here's a weird one. 2 to the 0 power, how many times do I write the base? None. So what the hell do I write? Nothing? Okay, let's test that theory out. New page. Let's take 2 to the third, 2 to the second, and 2 to the first. So we all know 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. Beautiful. Okay. There's a pattern as I run down here. To get from 4 to 8, wouldn't you agree I divide by 2? To get from, sorry, 8 to 4, I said that backwards. To get from 4 to 2, I divide by 2 again, right? On this side over here, I just drop the exponent by 1. So there's a pattern going on the left and a pattern going on the right. If we continue the pattern on the left, what's the next obvious exponent? 0, right? 3, 2, 1, 0, right? Countdown, blast off. On the other side, I should divide by 2 because that's what was happening. What happens if you take 2 divided by 2? Oop, try again. 1, there we go, yeah. 2 to the 0 power is actually 1. Let's make sure I'm not full of shit. What do you do when somebody says something and you don't believe them? Look it up. Where do you look it up? Probably Google. Right? We Google everything these days. So let's find Google. There's Google. Okay, so 2 raised to the power of 0. Google says it said 1. So Google agrees with me. It's 1. Okay. What's 3 to the power of 0? 1. What's a billion to the power of 0? 1. Okay. Yeah. It's a weird thing. It happens. We're stuck with it. Okay. So let's see. What else do we need to know about powers? Ooh, let's take this one step farther. Anybody want to get really crazy with math today? Excellent. Thank you. So what's the next obvious power if I take it down 1? -1. What the hell is 2 to the -1? Well, what does the pattern on this side tell us to do next? Divide by 2. So there's 1 divided by 2, isn't it? I claim it's a half. Shall we ask Google? Hell yes, let's ask Google. Okay, so Google, clear, what is 2 raised to the power -1? Google said it's 0.5. That's the same as 1/2? Yeah, so 0 power, nothing happens, you just get reduced to 1. If the power is negative, basically the way to think about it, it means flip the base. The base was 2. What happens if you take the reciprocal of 2 if you flip it? You get 1/2. What happens if I flip 1/2? What do I get? 2. So if I take 1/2 to the power -1, what should it be? Let's ask Google. I'll write the rule down. Okay, so let's see. To do that, I'd have to put the 1/2 in parentheses, I think. So I'd do parentheses 1/2. And then I would say raised to the power -1. And Google says, yep, Google agrees with us, it's 2. I think it still would have worked without the parentheses, but I like to be safe. So a negative exponent means flip the base. And we'll see that later on. So that, do you remember scientific notation, saying that in your past life? So scientific notation is a way to talk about real big numbers or real small numbers. So instead of having to talk about something that's trillions of miles away out in the solar system, we just talk about 10 to the power 12 instead. Way shorter way to write it, right? Think about nanotechnology. Anybody ever heard of that? Can we see nano stuff? No, it's wicked, wicked small. So we have to use scientific notation to talk about it. I think nano is like 10 to the -9th. I remember right? Let's look it up. Nano 1/billionth. Yeah, 10 to the -9th. Yeah. All right, so we're about out of time for fun with math today. What I would like you to do at this moment is take a look at your worksheet, see what you have done. Could you possibly finish it in 5 minutes? Or is this going to be your homework tonight to finish up? Okay, so give it a shot finishing it right now if you think you can finish it reasonably. Otherwise, you can turn it in tomorrow. I do expect it to be turned in tomorrow. If there's an answer you're just totally unsure about, don't worry about it. I'll give you some feedback. And then otherwise, what do you think you're going to do tonight for homework? Prep for 1-2. Yeah. And if anybody wants the 1-2 assignment, for those of you in the room, I'm going to hand it out. For Daisy and Jose, what I'd like you to do is finish up 1-1 stuff tonight, so work on the homework. If you get stuck on any homework problems, we'll go over them in class tomorrow, but definitely do the prep for 1-2. Okay? It's not that hard. I think you'll be okay with it. All right, so I'm going to shut up now. You guys do what you're going to need to do, and we will reconvene. For Daisy and Jose, so to turn stuff in, you have a couple of options. If you did it on a computer, there's a turn-in button in the lesson. So if I go to zoom out a little. Oh, wrong way. Lesson 1, right there. Student view. Student view. That's not showing it. No, there should be a submit button right here. Huh, okay, I'll fix that. There should be a submit button right here. If you did it on paper, then you can go to the front desk in Hermiston and they can scan it for you. Have them email you the scan, and then you can upload the scan here. It'd be better if we do it that way. So if it's already on a computer, cool. If it's on paper, have Hermiston Center scan it for you. They'll send you the scan and you upload the scan here. I'm gonna fix that submit button right now. Otherwise, you guys have a great day, and I will see you tomorrow on time. Sorry about the lateness today. Ah, there's the submit button. Excellent. Okay, excellent. It works. Let's see. Finishing up on 2 is not going to stop here. Yeah, if you're done with it, just put your name on it. What's that? Yeah, so you can either calculate and analyze the spreadsheet, send the spreadsheet, right? Or just use the spreadsheet on here. Everyone else.